Good afternoon to one and all present here with us today. I, Debraj Mitra, Deputy Director, Corporate Relations, KIIT deemed to be University, extend a very warm welcome to all our guests and participants present today for this interesting KweetTalk session on the topic Automotive Electronics, Emerging Trends and Opportunities. On behalf of KiiT School of Electronics Engineering and Kontempore, I would like to welcome Dr. Sanjay Muthal, CEO Kontempore, and the chairperson of this KweetTalk session for School of Electronics Engineering. Welcome to the session, Dr. Muthal. I would also like to welcome Professor Dr. Kumar Mahanti, Director Corporate Relations and Professor School of Management, KIIT deemed to be University. Welcome to the session, Dr. Mahanti. Now I would like to welcome all our esteemed panelists for this session. Today we have with us Mr. Murali Balasubramanian, India Innovation Head, Stellantis. A brief profile about him. Mr. Murali has over 27 years of rich experience in the automotive industry. He started his career in 1994 with Chrysler US as a product engineer within Advanced Vehicle Engineering. He currently heads the India Innovation Team for Stellantis, which is the fourth largest auto OEM in the world. Mr. Murali has worked on several groundbreaking products for Chrysler and FCA, including the first Jeep Grand Cherokee. He has been associated with Jeep Advanced Engineering Team for most of his tenure at Chrysler and later with FCA. He is also a recipient of the Vice President's Award for Engineering Innovation at FCA for the year 2011. Mr. Murali until recently was Head of Innovation for FCA for the Asia Pacific region. Earlier in his career, he had been associated as a key member with the global startup company Neilsoft Inc. and has also served in various consulting capacities with Renault Nissan, Toyota, Daimler, Mercedes-Benz, and Delphi. Mr. Murali has a bachelor's degree from IIT Madras in India, a master's degree in mechanical engineering and numerical methods from Clemson University, South Carolina, USA, and specialization in AI/ML from University of Texas at Austin, Texas, and McCombs School of Business. Welcome to the session, Mr. Murali. Now I would like to welcome Dr. Kumar Srivastava, our next panelist, who is the Director, Technical Project Manager, NXP Semiconductors India Private Limited. Dr. Rajeev is currently working as Director of Program Management in the Design Platform team and also leads the Bangalore Design Platform team in NXP Semiconductors Limited. Before joining NXP Semiconductors, he served in ST Microelectronics India for 18.5 years. He joined ST Microelectronics India in 1995 as S designer and served in different positions and became group manager in set-top box division, leading the SoC design. He did masters in physics with major in electronics from Banaras Hindu University and completed his PhD from IIT Banaras Hindu University. He has US patent granted on architecture for binary CAM with read and compare or write and compare operation in one cycle. He has a total of 7 publications in his name, published in various journals and conferences. Welcome to the session, Dr. Rajeev. Next, I would like to welcome Mr. MS Ashok, Director, Zuken India Private Limited. Mr. Ashok is a very successful engineering professional with over 35 years of experience in the electronics industry, covering test and measurement, GPS technology, and embedded system software development. He has varied and rich experience in setting up greenfield teams and business units. Presently, he is heading the India operations of Zuken Inc., Japan. Welcome to the session, Mr. Ashok. Now I would like to welcome Mr. Anil Ammina, Managing Director, BE Analytic, our fourth panelist. Mr. Anil Ammina holds a master's degree in reliability engineering from IIT Kharagpur and is a well-known consultant to many industries for product reliability study. He is the founder and managing director of BE Analytic located in Bangalore. BE Analytic is a leader in providing reliability and safety engineering services to the aerospace, automobile, medical science, oil and gas, nuclear, HVAC, industrial products, marine and power generation industry. Welcome to the session, Mr. Anil. Now I would like to welcome Mr. Sushanta Kumar Sarkar, Senior Expert, Vehicle Motion Control, Robert Bosch Engineering and Business Solutions Private Limited. Mr. Sushanta is an automotive embedded engineer with more than 18 years of rich experience, out of which 16 years has been in Bosch. He is passionate about innovation which can bring changes in life. He has been involved in all kinds of development and in every layer of embedded software and product development. He has 15 patents filed with topics ranging from conventional engine control to new products for the emerging markets. Warm welcome to you, Mr. Sushanta. Welcome to the session. Now I would like to welcome Professor Dr. Suprava Patnaik, Dean School of Electronics Engineering, KIT deemed to be University. She is also the moderator of today's session. Dr. Patnaik has completed her BSc Engineering and MSc Engineering degrees from NIT Rourkela and PhD from IIT Kharagpur. She has more than 30 years of teaching and research experience. She has served as faculty at NIT Rourkela, SVNIT Surat, and XIE Mumbai. She has also worked as a guest lecturer and big data research associate in University of Western Australia, Perth. She has nearly 100 publications in Scopus Index journals and conferences to her credit. She has successfully guided 9 colleagues, leading to award of degrees. Welcome to the session, Dr. Patnaik.
Good afternoon, everybody.
And finally, I welcome Dr. Arindam Basak, Assistant Professor, School of Electronics Engineering, KIT deemed to be University. Dr. Arindam has 7+ years of experience in education and teaching. He completed his graduation from the University of Kalyani, West Bengal, post-graduation from Jadavpur University, West Bengal, and his doctoral degree from the Indian Institute of Engineering, Science and Technology, Shibpur, West Bengal. His main research interest is thin film photovoltaics and sensor technology. He has authored a number of national and international journals. Apart from being a faculty, he is also the Associate Dean of Training for his school. Welcome to the session, Dr. Arindam.
Thank you, sir. Good afternoon, everyone.
Now, ladies and gentlemen, before we start with the panel discussion, I would like to present a brief background on KIT deemed to be University, KISS deemed to be University, and Kontempore. To start with, KIT deemed to be University, located in the beautiful city of temples, Bhubaneswar, was founded by Dr. Achyuta Samanta. We offer undergraduate and postgraduate courses in engineering, biotechnology, medicine, management, law, computer application, rural management, and so on and so forth. We were recognized as an Institute of Eminence in 2019 by Ministry of Human Resource Department. And last year, we were ranked #1 private university by Atal ranking of institutions on innovation achievements. Kalinga Institute of Social Science, KISS deemed to be University, is the sister concern of KIT deemed to be University. And it takes care of more than 30,000 underprivileged tribal students from KG to PG, completely free of cost. And last but not the least, Kontempore is a strategic partner to KIT deemed to be University, and KweetTalk is part of it. Started in 2018 as a knowledge management group, today it has transformed into a digital company which deals with knowledge and business solutions. The product and services under the Kontempore umbrella are leadership solutions, which consists of executive search, assessment, talent listing, and sourcing. Then we have business solutions, under which we have digital transformation, e-procurement, and simulations. And research and analytics, where Kontempore has a very strong research and analytics function, which acts as the foundation for all the products, solutions, and services that we offer. Going forward, I would request Dr. Patnaik to moderate the session and take over from here. Over to Dr. Patnaik. Thank you so much.
Thank you, Debraj, for that short and sweet introduction. Good afternoon, and again a warm welcome to all the panelists, guests, students, and everyone present in this virtual platform. Before we start this KweetTalk, let me say a few words about our school. School of Electronics is one of the major schools of KiiT deemed to be university in terms of student intake and stakeholders. Main objective is to impart teaching towards BTech, MTech, and PhD degrees. School has state-of-art facilities to promote research and consultancy in frontier areas of electronics, communication, embedded system designing, etc. Let us watch a small video about the school, highlighting on its infrastructure and the activities carried out at our school.
Right away, ma'am. Right away.
So, yeah.
We'll just have a small.
Okay, so that was a bit about our department, School of Electronics. So without any further delay, let us start the quick talk. And for this today, we have a panel consisting of eminent members having long experience and involvement in different capacities. And today the topic is automotive electronics, emerging trends and opportunities. So as we can see that the automotive industries has been witnessing a rapid evolution. It's not only the electronics, but the technology starts from the theory of propulsion and it extends up to the connectivity. So let us see how our panelists look at it. So now first I welcome Mr. Murali Balasubramanian. Sir, kindly share your views, how you look at this automotive electronics.
Can you hear me?
Yes, sir.
Yes.
Yes, and I'm sharing my screen. I don't know if you can see my screen.
Yes, it is visible.
Yes, it is visible.
You can continue.
Okay, so first of all, I want to thank KIT for inviting me to this talk. I've visited the campus. I'm pretty impressed with the campus, and I'm also a great admirer of Sri Mahanta. So I think Achita Samanta. So I'm really honored and privileged to be part of any activity within KIT. Speaking of the topic, I think automotive electronics has become the huge, shall we say, transformation and huge, inculcation into the automotive vehicle. And I'll speak to some of the latest and emerging technologies. I think that is the topic. So I'll share a few slides and I'll go over it very quickly because I have only 5 minutes. So I'll talk about some of the key trends that are emerging, and then we can take some more in the Q&A. Okay, so first of all, the big area where we are seeing, especially in the last 4 or 5 years, is the connectivity and infotainment area within the vehicle. So how well can we connect the occupant and driver in the vehicle to the external world? How can we connect the vehicle to the infrastructure, etc. So how do we, for example, 5G connectivity is becoming a huge area of research, focus, and implementation. Cloud-based services. How can we use cloud-based? You see, the vehicle generates a whole lot of data. So much of this data is procured by the sensors in the vehicle and then pushed to the cloud. And how can we use the data residing in the cloud to help the customer, for example, to customize the maintenance for him or her. So depending on how he's driving the vehicle, depending on how he's using the systems, where he is using it, what kind of conditions. So the maintenance can be actually customized. This is an example of how we use cloud-based services, especially where we are seeing a lot of activities, this personalized driving experience, enhanced and personalized driving, whether it's a number of displays in the vehicle or having a personal assistant in the vehicle, voice assisted commands, those kind of things where you are able to enhance the driving experience, whether it's from a entertainment perspective, information perspective, or climate, customized climate control, or you can have acoustic and other lighting, etc. Many of these things are really driven by various infotainment systems in the vehicle. Of course, you are getting a lot of these new user interfaces. For example, navigation with augmented reality. This is a new area of a lot of focus and deployment coming in the next generation vehicles. You will see a lot of augmented reality, projected screens and stuff like that. High definition maps, heads-up display. These are all big areas. And then one more emerging area is what's called this LEO satellites, so low Earth orbit satellites, where you can dramatically improve the connectivity. So that's the next or the alternative to 5G. So these are some of the areas within connectivity and infotainment. We also have a big emerging area in ADAS, advanced driver assist systems, basically enabled by electronics in the vehicle. Safety and sensing is enabled by electronics. So what kind of big focus research is going on today in the industry? We are looking at multifunctional sensors, which is optimized. So today we have more than 130 130, 125 sensors in the vehicle. How do we optimize it? Reduce the number of sensors, make it multifunctional, make it more intelligent, intelligent camera, for example. So that way the handling the data from these sensors can be a little bit more optimal or a little bit more computationally efficient. So what kind of sensors we're looking at? 360-degree external sensing, occupant and cabin interior sensing and monitoring, and then of course biometrics. So these are some of the sensors that we use for various applications, specifically ADAS. We are targeting higher level of automation. I mean, just recently, most of the companies are moving to L3 plus, L3 between L3 and L4 level of automation. So for those who know the levels of automation, this is very big. It is taking more and more out of the driver's hands and making the driver less and less amenable to making mistakes. And of course, a lot of these engines are run by software in the vehicle and intelligence built into these applications. So a lot of AI, a lot of simulation, a lot of data management, and a whole lot of software development happening within these this domain. Then you have, of course, electrified propulsion. That is, you see it's fast emerging in the next few years as the most viable vehicle choice is the electric propulsion. So we are talking about, therefore, a whole lot of change in terms of how we look at the architectures. So when you look at electrified propulsion, the architecture, when you look at the architectures, electronics architecture, it's going to be different. It's going to be new. It's going to be a whole lot different from what we had in the last 30, 40 years. A lot of these accessory and energy management controls are now entirely handled by and automated by the electronics in the vehicle. Of course, battery technology and energy storage and conversion, these are big topics, and range enhancements and stuff like optimization of the consumption, optimization of the storage, etc., is being looked at heavily today as a research area. Of course, advanced power electronics, e-motors, etc. Motors are a huge area of focus and research. And the other area of importance is the electrical architectures, becoming more and more advanced. That I just spoke about a few minutes ago. We are getting towards more service-oriented architecture. Using middleware, you are talking about optimized ECUs, vehicle centralized computers, more power, with a lot more horsepower in these ECUs. We're talking about cloud connectivity and extensive use of automation with Ethernet backbone. We are talking about plug and play features, so that way you can get the cool stuff developed by the suppliers to just plug in and play in these architectures. So enabling those kind of modular architectures is a big thing. Of course, looking at multi-core CPUs, high-end microprocessors, advanced motor control, higher efficiency, which is no longer requiring the engineers today to write algorithms. It's all available off the shelf. Okay, so this is basically what I wanted to say, the major trends emerging. So as electronics engineers, you should be proud that you are in these times in the world, because even in our company, we are hiring 50% or more electronics engineers. And with we are teaching our non-electronics engineers a lot about electronics, and that's consuming a whole lot of effort for us. So especially given the emerging trends like electrified propulsion, connectivity, etc. So you are you're very fortunate to be in these times where electronics is a big need in the automotive industry. And I think especially for universities, I think you should be looking at electronics core engineering, but also with a lot of specializations with industry applications. So with that, I'll hand off. I think I took my 5 minutes time, and I'll hand off to the next speaker.
Yeah, thank you, sir. So very quickly, we just highlighted on all the automation that is possible and where we have the electronics. Now moving forward, so before that, I request all the participants, in case you have any queries while these presentations are going on or our experts are sharing their views on this topic. If you have any queries, you can type your queries in the chat box. Subsequently, depending on the time, we'll see how many queries we can take off, and we'll request our experts to highlight their views on these queries. Now okay. So moving forward, we have in the list Mr. Sushant Kumar Sarkar. Okay. So now it is over to you, sir, to share your views on this topic, that is automotive industry as a whole and electronics in particular.
Hello, thank you, ma'am. And also thanks to all of you who are in this forum today. I'm also very lucky to be part of this session. And I saw one photograph, ma'am, what you in the video there. I was part of the recruitment team. I was still remember your campus, and then it's experience for whole Bosch team to be there. It's quite, I think, 2 years old video on. I still remember your nice campus, and then all the warm welcome we received. Yeah. So I will just like to extend on the similar line, like Mr. Murali said. So just to continue in the similar line, see the autonomous driving or the ADAS topic or topic is a buzzword for all of us in the world. Actually, we all want to see the dream reality coming true. And then every one of us are working towards the similar direction and levels. So if I see electronics and embedded system as a whole, they have a lot of things to do and give it to this domain in principle. So if I see the bits and pieces technologies, where some of them were existing, like video-based perception, ultrasounds, use of radar, so use of LiDAR, so many technologies were there. And now it is up to this whole fraternity of engineering, business, as well as research institutes to bring them on the ground. Yeah. So if I see my view, it's available. Some of the technologies are available, but then overall strategy is what is emerging now. It's getting developed to reach an automation level, as Lisa said, that level 3 or level 2 plus automation is still some of the OEMs are trying to offer, including Tesla. But then we see that as a general to all of this industry, it's still evolving. A overall strategy is what is getting developed. And then all this 360-degree view or sensing like a human being, how we hear, how we see, and how we perceive our environment, and then decide in fraction of second in a memory or brain, which is a really very challenging things to do using the technologies what we have. Even to achieve a normal driver's capability, it's really challenging. Was we know this is happening, but then on the development side, this fusion, or rather how we will ensure that a right path has been selected, or a right perceptions, we are able to detect every object, and then a static one or a dynamic one, or they are just a shadow. It's really challenge to use all of our technology and know-how on the system, and also on the side. I mean, to how automotive engineering or electronics engineers are programming them, or how they are controlling each and every device, when to push, when to brake, and when to steer. So these are the basic fundamental development strategies what development is happening. I would also like to draw to all of you where we are seeing the challenges on verification and validation. So you all know that in the AD topic, theoretical estimate says that, okay, if you want to validate each and every test case, or rather use case where it may land, even in such a small chance we cannot take in such a safety critical system. So it's a huge effort, and the research is going in this, and which I would also appeal to you community, student community, and also industry to research that please look on this, how do you can develop a algorithm which is necessary to test, or a upgrade is happening on the future, and then only test that is necessary. Something like a test-driven development, what we say. That means when you develop, you know what need to be tested and at what level need to be tested. Is it on the vehicle level or a subcomponent level and the software level? So these are the areas where we are seeing challenges. We have certain methods and tools, so-called, is getting developed, whether it's a system in loop or software in loop, many things you can think of. But then we see that research in all the advanced countries, including ours, probably your school is also, should look on how can we validate what we develop in a meaningful way. That means there will be probably thousands of transition, one state, vehicular state to another one. But then if it was tested, behavior was known, then we should not test, or something in the similar line. We are facing challenge here as from representing Robert Bosch. We have also similar system and challenges which we are taking along with universities. And then we want to develop a system which will help us to validate. Yeah, not only develop our concept, but also will give us as much as efficient validation concept, which will give a confidence level of at least equal to a standard driver's behavior or the perceptions. So that I should say from my side, that please look on the development, the opportunities. We need also the domain guys and their experience, but we need a better implementation strategy on all the sensors what we have. Fuse them. A fusion is probably what everyone is. We are also trying, but then fusion will not be only solution, or which we may not be the right strategy what we are looking for in the reality. So we are experimenting, and please look for a whole development which should not be a classic one. We cannot really fulfill all our needs and the requirements. And you guys are there to help us, to help industry. File your ideas, do research, publish paper. Probably we pick up something brilliant from one of your ideas and then develop it. So I will be looking forward. And that was all, ma'am, today from my side, MS student community. Yeah. Thanks a lot. Over to you, ma'am.
Yeah. Thank you, Mr. Sarkar. So moving forward, we have Dr. Rajeev Kumar Srivastava, Director, NXP Semiconductor India Private Limited. I believe that semiconductor is the heart of electronics. Sir, just share your views on this topic, that is automotive electronics. What are the emerging trends and the opportunities?
Thank you, madam. So, as you know, I worked in ST Micro and then in NXP, and both companies were involved in a lot in automotive electronics. Now, I have seen that since 1995, earlier the electronics content in automotive was very less, and it started growing. And now, so for example, I have one benchmark that in BMW, there is a $600 of electronic parts. So that tells the story how fast electronics has gone into the automotive industry, and that's a requirement actually. Now, I'm thankful to KIT to invite me in this talk, because I was very much associated with this. And as an NXP, I can tell you that because NXP, 50% revenue comes from automotive industry. We sell our electronics to them, to all automotive industries, to almost all. And as Murali and Mr. Sarkar was talking about autonomous cars, so we are very much into it. But I will come into that later. But just to tell you that in automotive, as I think Murali was saying about sensors. So sensors, one of the key interface for any car. Let's take example of car only. Either it's a tire pressure monitor, or it's a high-end radar system where you see how far is the obstacle. Maybe it's on the side of the car, or maybe in the front of the car. And then also you have a video. Video is also sensor. But the most important is the ranging system, which is basically LiDAR or a radar. Now, NXP is very much involved in that, and we have a radar for automotive cars which can go up to 2 kilometers. And then you have small range radars which take care of all the periphery part, up, down, just to ensure that your car is safe while driving. Now, it's not only autonomous car, even the driving assistant is very important. Even if you, while driving, I mean, even today you have seen in some cars that if you are driving or if you are parking, you get a lot of assistant from different sensors on your screen, which helps a lot. You know, parking is a big problem in India. It's a small thing, but makes life easier when you have a nice sensors integrated with a high processing system, which gives you the perfect information. Now, so you see where electronics is. So electronics is right in the engine control, where it controls the movement of the petrol engine. I mean, through injection, proper injection, and all those synchronization. Braking system, infotainment, all the entertainment, radio, car radios. So just to tell you that you all are aware of AM and FM radios in the car, but now the next standard is digital radio, which is a digital data transmission through amplitude modulation. So it has a wider range, because FM has a smaller range in a city. It's it's a point-to-point communication, so it stays around the city. But if you are transmitting your data through AM, it can go beyond cities, as you know. And since it is digital data, so there is no noise. So the quality of audio is like FM channel. So that is also in place, and NXP is one of the leaders in that, in car radio. Then we have a car access system. So these are a very small thing, but requires a lot of electronics. So car access is something which you all know, the remote. I mean, you have, I remember earlier we have a car where you have to move your keys to open the door. But now you have a remote or a key, a remote integrated, where you just push the button, car will open. Then nowadays you can see, I think for last couple of years, you don't have to insert the car into any socket. You just put it in your pocket, and through RFID, it recognizes that you are inside the car, and you push the button, car will start. This is the latest stage. Now, what is next? Can you imagine? So we are ensuring that now your mobile phone becomes the car entry. So that is the next stage on which we are working. Similarly, we have automotive microcontrollers. So right now, automotive microcontrollers were focused on engine control and controlling the whole network, where it integrates all the monitors like tire pressure, temperature inside the car, temperature of the engine, all those things integrated together. Now, next stage, you see that boom is for electric vehicle, which is a very nice solution, by the way, because it reduces the pollution, both noise and atmosphere. And with the coming of electric vehicle, the scenario has changed, because now microcontroller has to control the charging of the battery. And by the way, charging of the battery is not as simple as we have the traditional batteries, because the lithium-ion cell requires a lot of smartness in charging, because it has a series, it has a combination of series of and parallel battery cells, which requires a very smart charging. Otherwise, it may go wrong. So that battery management system is also in place, and it's becoming smarter and smarter. When you are going downhill, it will also use that energy to charge your battery. So there are a lot of things, and these are all electronics. And just to tell you that it's electronics plus the software, and software is also embedded software, which again is electronics. Let me tell you very frankly that software is very wide, but embedded software is something where you should know the hardware, the architecture of the processor. Then only you can write a nice or good embedded software. So why I'm telling this, because for students of electronics, just try to understand that the options are much higher than what you are seeing today. Now, again, coming back to other things. So I just saw in the video that electronics department has also a focus on healthcare. So just to share a few things that we have a lot of healthcare products also, like glucose monitoring system for diabetic patients and other things. And in fact, you won't believe it, in epidemic situation, we used our tire pressure sensor monitors to be utilized in making medical equipments like ventilators. So electronics is one of the key for either it's a petrol engine or electric vehicle, and it will continue to grow because we are adding a lot of automation into the cars. So it's still growing, and it will never stop, in my opinion. Thank you.
Thank you, sir. So moving forward now, Mr. M.S. Ashok, Director, Zuken Industry India Private Limited. So now it is over to you to share your views on this topic, that is automotive electronics, emerging trends and opportunities.
Thank you, madam. And I would also like to thank KIT for this lovely session that we are having and the opportunity to participate. Just give me a moment. I'd like to share my screen so that we would be able, I like to have visualization on what I'm trying to say. Okay. I hope you're able to see my screen now. Yes.
Sir. Yes.
So, with the topic, and my other esteemed panelists earlier have talked about a number of things in the emerging technologies and things. I would like to very quickly give you a couple of other insights to this whole emerging trends and opportunities, especially as students wondering what does all this mean for us. A very quick background, we are from a company called Zuken, and we are a Japanese multinational. We are especially working in the area of software design tools, especially what we call as electrical CAD, ECAD. Just like you mechanical engineers, students are aware of tools to do your mechanical CAD work. We have electrical software tools to do electrical CAD. We are a 44-year-old company, highly specialized in the area of PCB and wire harness. I'll come to that in a moment. We operate out of India, and we are a tools manufacturer who are at the bottom of the food chain, a very necessary part of the entire food chain of design. With today's complexity of whatever designs that we are doing, it has become eminently necessary to have good design tools which help you to do your designs. And we address a whole lot of companies across. Some of the panelists we have are our customers, they use our tools. In particular, in India, I'm very proud to say that Department of Space is one of our largest users, and almost 9 out of 10 PC boards and system designs which fly on the satellites and on the rockets are designed using our tools. It's a very proud moment for us as the number of users in India who do extremely high-end designs. This is what I will be concentrating on as we go forward. So, look at the evolution of automobile, electrical, and electronics. For some of you, all of you should be able to recognize this 1908 Ford Model T. Beautiful car in those days, first mass-produced car. And what was inside in electrical and electronics? A couple of wires, a few switches, batteries, and move 100+ years to the most glamorous face of our automobile industry today, the Tesla. And if you were to just kind of look inside, that's the kind of wiring which exists inside. That's the kind of electronics which goes into these vehicles. Extremely complex. Complexity has increased tremendously. And like Balasubramanian sir were mentioned, today the number of sensors in the car is huge. The back-end systems are many. Electronics has become very complex. And obviously, when it becomes complex, calls for a lot of innovation. And that's where we look at young engineers. So today's car not only is, it's become more a computer, honestly. I think, correct me if I'm wrong, the total amount of computing power in any of today's high-end cars, even a low-end car, is much more than what you carry on your laptop, right? So what does this all lead to? The opportunities for electronics engineers are very high now, right? So we take a look at some of the characteristics of the automotive electric equipment, which is also will tell you which way the design activities travel. So there are a lot of variations, product design, a lot of variants come in. There is a lot of miniaturization activity going on in the designs to save mechanical electrical power. There's a requirement of high speed. You want to get into the car, turn it on, and all systems should go live very quickly. And you go store enormous amounts of data. Today's some of the trends which my co-panelists spoke of also require fast memories to be designed into the systems. And safety, of course, is paramount. So you are designing for a safe, reliable systems. These are driven by safety regulations like the ISO 26262, and which also requires a lot of traceability and evidence. Why I'm talking about all these factors is that as engineers, today, automobile engineering has become a multidisciplinary activity. Yes, software is very attractive, and therefore today a lot of software runs on the cars, but software requires a hardware on which it runs. And good hardware design is very critical for the entire system to work. So even when you come down to the fact that I am a very good designer, I have designed my circuit very well, there is still one more step. You have to make a very good PCB in order for the hardware to work very well so that your software performs equally well. So there is a lot of opportunities as we go forward with all these design trends. Okay. And today it's a design work in the 3D world. And there is a lot of 3D activity involved, whether you're talking of mechanical structures, you're talking of electronics, design of the boards, designing of and analysis of the boards, interconnectivity, and data moves in between mechanical guys, electronic people. And so there's a lot of multidisciplinary activity which goes on. Okay. So, and as you can see, complexity has been increasing. So if you were to visualize an automobile wiring for it in 3D, this is how complex the whole system looks. Calls for innovation, calls for good understanding of your basic electrical and electronic engineering skills in order to be able to help design the cars which are being designed today. PCBs, like I said, all electronics eventually lies on PCBs. And today we have moved from very simple PCBs to the most complex of PCBs. Dr. Srivastava pointed out about miniaturization and wanting to have a lot kind of factors built into the semiconductor, which basically means that the semiconductor itself is getting more complex. We have moved from a point of hard boxes and hard boards of PCBs to flexible material. We have PCBs which can fold, brings in miniaturization. We have PCBs which are in all sizes and shapes. And these are the emerging trends and challenges which require good engineers. And therefore, the opportunities that you have as engineers is enormous. You have design work, you have design work going down to the work of developing good PCBs and harnesses, to analyzing this. You have a lot of analysis work which you do. So, and you interact with other multidisciplinary activities. So there are a lot of opportunities in the automotive sector for good hardware designers. So you do not forget any of your studies which you have done. When we do high-speed designs, everything of microwave and transmission line theories will walk into place, right? So it is very exciting, and and like Balasubramanian sir pointed out, you people are here at the best point in time. It's so much activity happening and opportunities coming up. Talking about one more step, where it's gone pushed in, is the fact that Dr. Srivastava said that they're making all kinds of very complicated chips, right? So you are already studying VHDL and VLSI as part of your course, and which gives you the opportunities to look for, challenges there. There are some more challenges in the VLSI area, which is coming from packaging. The ability to actually effectively package all this into a small little end component itself is very challenging. And this is pure engineering work, okay? And it calls for a lot of good application of your engineering skills. So there is tremendous amount of opportunities as we go forward. So in the current situation with the automobile industry, newer challenges are coming up in the design aspects, in being able to develop all these very interesting applications, and supporting that all the electronics. And within the electronics, there are so many areas of work which a good engineer will find the opportunity to innovate and contribute. So this is how the scenario looks, as what we would like to say. And with that, thank you very much, and I hand it over to you, madam.
Yeah, thank you, Mr. Ashok, for highlighting on how PCB is also essential for automotive industry. Moving forward, may I request now Mr. Anil Ammina, Managing Director, B Analytic. Sir, please share your views on this topic. Is it there?
I think Mr. Ammina, you are on mute. Mr. Ammina, please unmute yourself.
Yes, sir, please. Sir, please unmute.
Better. Yeah, still unmute. Mr. Ammina, please unmute. You are on mute. Oh, there is some issues, I think. He says that he has unmuted himself.
Audio issue from that side.
No, it's still, we are not able to hear you.
How is it now?
Yeah. Now I can hear you.
Yes, sir. Yes, sir.
Yes.
Okay.
Yes, now it is audible, sir.
Thank you very much for inviting me onto this session. We don't do electronics design, but we do qualification of electronics parts at our B Analytic. So I want to come out with a different story. We work on reliability and safety of different engineering products. Our revenue, 50% of the revenue comes from the automotive electronics. We do testing and qualification of components and subsystem level testing and qualification and certification also. So and remaining 40% comes from the defense electronics and 10% from the medical electronics. So I want to be little offbeat. I don't directly talk on automotive electronics, and I will take that during the question and answer session. So I want to combine this topic along with the story of India's success. Okay, so when we got our independence, we started purchasing used defense equipment. Okay, but India is basically a knowledge-based society. It's a knowledge-based society. with a minimum of funding, we could able to manage sending rockets onto the Mars and did a lot of marvelous things with respect to engineering. Okay. So initial days, we used to get our, defense equipment or any high-end electronic equipment basically from some countries which used to deny initial days. Then we aligned somewhat, even though we are a non-aligned country, we are aligned towards the USSR, and we used to get some of the defense equipment from them. Then we entered into another story of, licensed production. Now India is in a position to supply defense electronics or basically electronic products to different other countries, and we are slowly becoming self-sustained in this area. And if you see our automotive electronics also, there are a lot of good things happening. Even though the brands are different, they may be German based or they may be US based, but most of the R&D is happening in India. And being as a test lab owner and a reliability and safety engineering services company, I am seeing a lot more and more Indian customers coming to us for qualifying their products. Okay. And don't assume that those companies are very big like Mahindra Electric or somebody else. I am seeing companies who are just 10 people companies, young engineers, starting their story with EV or BMS or battery management or some other system within the automotive. Some are coming out with the two-wheeler. Okay. So what I am saying, speakers already talked about what is happening in the automotive electronics. Okay. Here I wanted to mainly point out, as a engineering society, and particularly the electronics engineer, having a responsibility to come out and start something so that we can give our helping hand to the success of the overall India, the India's success story. Okay, and the days of entrepreneurship with the Kirana shop or a small hotel or a pawn shop is over. Now we have to boldly come out and start something which should be at a scale also. Not only innovation, but it should be scalable. Okay, so with that, I want to conclude. I will add more with respect to reliability and safety along with the automotive electronics section. So I'm handing over back to the team.
Thank you, sir. So now it is 1:30, so we'll take some questions from the participants. So I can see there are many questions popping up. So some of the questions I may combine, and depending on the time, we'll see how many questions we can take up. So one of the questions I can see in this is, it is to Mr. Murali Balasubramanian. Sir, the question is, how do you think electronics is being a game changer in vehicular engineering? Especially in the last 3 to 5 years, what are the most significant development in this field? Over to you, sir.
Thank you. Thank you for that question. Can you hear me?
Yes, sir.
Yes, sir, we can hear.
Okay, so that's a good question. I think if you see where we were, the kind of design or engineering that was happening for vehicle engineering was vehicle centric. What can we do to improve the vehicle? What can we do to make changes to the vehicle to make the vehicle more aesthetic, more efficient, power consumption wise, more better drivability, etc. Now today's engineering is focused on the occupant. So that is a major shift. The human-centric engineering is one of the major changes, and most of the human-centric transformation, the focus on human-centric engineering is coming through electronics. What I mean by human-centric is we are not focusing on the car, we are focusing on the occupant in the car. It's assumed that the occupant is traveling in the car. Therefore, the car has to be efficient, propulsion efficient or a safe. But when you look at active safety in the vehicle, to be able to assist the occupant or driver of the vehicle to be able to save them from themselves, from their own mistakes. So that's where you have active safety, things like autonomous emergency brakings or electronic stability controls. So these kind of things are electronics. So safety is human-centric focus, and active safety is a huge enabler for it, and that comes from electronics. Another one is comfort and convenience. So we want to make the customer, earlier it used to be you have a seat, you have a space, and you have a steering wheel, drive the car, that's it. Or you have a seat for the passengers and that's it. But today you have, how can we make the occupant more comfortable in the car? Comfortable from climate point of view, through climate control, which is intelligent. Entertainment, so to be able to enable the customer or occupant to access the entertainment on a need basis without using smartphone or any of these things, without touch, for example. So just voice activated entertainment or infotainment, information, where we are, what are we doing, what's the news, everything can be now available for this. So the occupant infotainment, entertainment in cabin experience is enhanced, including how comfortable he feels, etc. So we are talking about safety. We are talking about another one. We are talking about is comfort and convenience in the car. And then the next one we are talking about is connectivity. So how connected is the human to the external world? Not only at a level of connecting to the internet, but more so connecting to the cloud, so you can actually do work while you're traveling. So you can actually work with data intensive activities. So you can access your cloud and do that. And that has to be enabled from the vehicle. So some of these, and then of course, the most important one is we are changing our whole, the quantum shift is going towards electrical vehicles, electrified propulsion. So there are so many different varieties. There is hybrid electric, plug-in hybrid electric, battery electric vehicles. There are so many electrified propulsion systems. This is in fact for automotive industry a sort of new technology, which means a lot of electronics, understanding of battery, understanding of how the power is transmitted into the vehicle, or power is used with the help of motor. For example, electrical motors have become a huge significant aspect. And then of course, lastly, the autonomous vehicles. At the end of the day, we want to build some sort of autonomy, so driver is maximum assisted while he's driving. So some of the things where there is emergency, there is a situation where he needs to be alerted, he or she is a little bit not so alert. So to be able to monitor the occupant, to be able to monitor the vehicle, to be able to adjust conditions in the vehicle is undergoing automatically. So there are so many things that are happening. So electronics is at the heart of all of these things. So when we talk about when we write down the top 10 technologies in the automotive, the top 9 is probably electronics. And then the 10th one would be lightweight materials, eco-friendly materials, and other things. So what I mean by that is, therefore, electronics is definitely the technology, and the evolution of hardware, software, etc. has enabled electronics to make a big change in the in-vehicle experience. For example, even in the voice personal assistant in the car. So car is no longer a transportation device, but more of a companion. So this kind of, the ability to make such a dramatic shift in the experience of traveling is a major impact only by electronics. So in that way, I hope I've answered the question. So, any clarification, please, you can write it in the chat.
Yeah. Thank you so much, sir. So now next, maybe I'll combine a couple of questions, and it is to, I think, Mr. Sushant Kumar Sarkar. Let me combine. There is a question on career, there is a question on research. So if I combine them, Mr. Sarkar, can you just respond to this? What are the recent developments and challenges still being researched in the automotive engineering?
Yeah, so as all of our esteemed panelists was, so we
Some audio problem?
Yeah, Mr. Sushant, we are not able to hear you.
I think he got stuck. Yeah. Maybe we can take it as a third question. Meanwhile,
Yes,
you can
yes.
transfer.
Yeah.
Maybe I can add
Okay,
few things.
let me pick another question. So later on, we'll come back to Mr. Sushant Kumar Sarkar. So it is to, may I ask to Mr. Rajeev Kumar Srivastava, the question is how electronics is helping in making autonomous car a reality?
Okay. Thanks. That's a good question. So I think Murali already covered some part of it. So autonomous car, you know, it's a driverless car. And so what are the things which you do as a driver? You can understand. Now you drive it, you control it, you see it, you see the traffic, accordingly you drive. And nowadays you see also the Google map where the traffic congestion is that, so that you can avoid those routes. Now all things should be done by a car, then only it becomes a driverless car. So as I said earlier, that we have a radar system to detect the objects either on sideways or in front. Sideways with a small distance, and in front we have a long distance radar. The next step into that is communication, vehicle to vehicle communication. We call it V2V, or vehicle to a base station communication. We call it V2X. So that means the next step, I mean, the most important thing for autonomous car is connectivity among the cars. The cars should talk to each other. So for example, two cars are coming, approaching a crossing on two different sides, say east or north. And there is a chance that if they remain with the same speed and there is no red light, they will collide. Now, if those vehicles know each other that they are approaching the same point with the same speed, they can talk to each other and one car will slow down. That's the ultimate thing which we want to achieve for autonomous car. And that's what we are working on. Now, when this research started for autonomous car, that time even 4G was under deployment. It was not available. So that time people focused to create a Wi-Fi network along the highways so that car get connected through the Wi-Fi network. But you know, it's not very simple solution. So then with 4G and now 5G coming in, most likely 5G will become the medium to connect between cars and car to a base station, maybe a traffic controller or whatever. It may be your home also. So that connectivity is very key. So first thing is sensors, set of sensors which detects what are the surrounding and in front of you. Second is connectivity, and third part is data processing. Now that is also very important. You have so many sensors, even sometimes you have a video also, all coming to a processing unit, which you have to process all the data, take a decision and drive the car. And this should happen in the real time. So that's a big challenge. And you know, it requires high compute power. Now there also people are thinking, if we have a nice, good connectivity, we can do this computing even with clouds also. People are thinking up to that. So you can imagine the speed of data processing they are planning. Or they should have a very nice or very high-end processor sitting inside the car, which can do all the data processing. Now, you know, there are a lot of cars, Google car, Tesla, which are driverless, and a lot of trial runs are going on. I cannot name which company, but NXP is part of that. And we are part of several autonomous cars. And we are supplying a lot to them. And so, I mean, if you see, Indian traffic may not be a very good solution for India, but still the features used in that autonomous car can be used as a driving assistant to the drivers. So what you can, I mean, what can be done, that we have a lower version where you have a very close to automatic car, driverless car, but you control, so that then in case of emergency, you take the control. And that is also going to give you a big relief. And this is all possible because of electronics. So that's the key. And with electrical vehicle also, either it's electrical or petrol vehicle, the electronics remains more or less same for the autonomous car. And as a student, yeah, you have a lot of opportunities here. Being an electronics student, either you can be an analog designer, which can work on sensors. You can be a digital designer, which can work on high-end microprocessors, or you can be an embedded software guy. All is applicable for automotive. One thing I want to just share, which is important. So NXP is, I hope you can see my screen. So NXP,
yes, sir,
yeah,
visible.
Running a program we call NXP Campus Connect, and you can see you can connect this through a LinkedIn. So we have a lot of technical leaders who keep on giving lectures, not a very high end lectures, but a lecture very close to students. The topics are very close to students. So I would recommend you to join this and group, and you will get the invitations. I think it's monthly one lecture, but topics are very nice and it's suitable for all the students. So please join that. That will help in learning some advanced topics which can help you to build your career. Okay, thank you.
Thank you, sir. So now another interesting question, that is, may I request Mr. M.S. Ashok? The question is, what are some of the critical design issues in the development of automotive electronic equipment?
Thank you, Madam. That comes down to some very basically core engineering issues which have to be addressed. If you recall in my earlier discussion, I did talk about certain specific automotive electronic characteristics. What is very big challenging today is the requirement of miniaturization both on the mechanical and electrical side, okay, which is, otherwise if you have too many of these electrical boxes inside the car, then the space available for passengers' comfort would go down. And power consumption is the other issue. So with the increased number of ECUs, the challenge to miniaturize with good power saving has been one of our critical areas of work. And moving forward, we are also seeing the unification of actuators within the, with the sensor, especially with resistance to heat. Okay. So if it is a regular IC engine, there's a lot of heat in the certain areas, especially near the engine. And so you need to have design issues attended to from being heat compliant, right? There's also a lot of requirements for high speed and safety. And as my previous speaker also mentioned, you're trying to do a lot of computation. Your software is trying to do a lot of things, which means that you have a requirement of having high speed designs. And high speed designs also require high speed memory. And high speed memory, the moment you start getting into higher frequencies of design, all your other problems start showing up. And therefore, the need for high-speed processing in real time, especially for things like ADAS, auto driving, is a big challenge when you do your design, say the electronic design. Yeah. So some of the other broader challenges which exist also in respect to the design activity for automotive electric is I mentioned about high speed, and so the ability today to be able to simulate and validate your designs before you actually make it is another challenge. The world has moved from the earlier days when you would actually build a full mock-up to figure out that all your designs are working fine. We have moved to an age of, with good computing power, to an age of simulation, right? And simulation is a very challenging topic. So whether it is simulating all the mechanical structures, but also in as much as simulating the electronic behavior of your circuit. So your signal analysis, signal integrity becomes a big challenge, right? A small tweak here and there can actually make it difficult for the system to perform well. There's a lot of challenges when we are transferring data between electronic to MCAD. There are challenges in the electromagnetic interference. Today's electric cars is one of the most noisiest, electrically noisiest environment that you can be in. And therefore, the ability to design your circuitry well to not put out a lot of noise, electrical noise, and also the ability to withstand noise coming from the outside is a big challenge. So these are some of the areas, and I'm highlighting this from that perspective that as engineers, today's engineers, you have so many areas of specialization and skill development within the electronic engineering aspect. So there are a lot of good challenges, and again, repeating, you are in very exciting times. Thank you.
Thank you, sir. So it is 1:49. Let me pick up the last and the final question. Maybe may I request Mr. Anil Ammina? It is on the safety and reliability, and the question is, how do you think about reliability and safety when it comes to automotive electronics? Mr. Anil Ammina. Sir, please unmute.
I shared a screen. Is it visible to you?
Yes, sir.
Yes, sir. Yes, sir. It's visible.
So that talks about the overall automotive electronics and qualification. Why reliability is important? It is to make a brand or a break a brand. Okay, you need to able to estimate the life forecast so that you don't end up paying the warranty cost, which is more than your margins. Okay, so that is one area, and the same reliability engineering is used in predicting the failures, and so that we can manage the preventive maintenance or spare part management. Okay, so this overall, this is one story, and another story is the particularly component and subsystem levels, simulating under the extreme environmental conditions, still your product will work or not. Okay, under use, abuse, and misuse cases. Okay, will your product still work or not? So reliability engineering will help you to identify all those issues early in the design and production phases so that you can give a better product to the customer. So that is one area, and another area which is fastly emerging into the automotive electronics, the automation. I think Murali sir and Rajeev sir and others gave the nice introduction about the automation. Okay, so earlier it started with a simple power window automation. Now we are talking about complete autonomous vehicles. Okay, so when you are automating your through electronics, that means you are replacing mechanical parts and depending on the electronics for the processing, communication, and decision making of the vehicle movement, basically. So whenever you do automation, there will be two questions. One question is, for example, I will explain that with an example, automatic emergency brake system like AEB. Okay, so that has to work when to avoid a forward crash. So particularly when the driver's response is not enough, okay, so that the AEB will come into picture and it will control the vehicle by applying the emergency brake so that it can avoid the imminent forward crash. So now let us take this example and consider two different cases. One case is, will it work when it really requires? If that won't work, what will happen? A hazard, a fatal accident. Or another question comes because of automation is, will it work as intended, or it should not work when it is not intended? Unintentional function should not come out. Like you are driving nicely and suddenly the emergency brake will automatically gets applied. And you are actually trying to avoid a forward crashing, but it will it will lead to a backward crash because some other vehicle will come and hit the back portion of the car. Am I right? So this ISO 26262 is one of the standard which will talk about the SL rating of the automotive functional safety basically. So all the functions are verified through design, quality management, and functional safety. Okay, and also through the reliability analysis. Okay, whether the system is safe enough for that particular application or not, judge. So my suggestions to the students, apart from the regular, the basic core electronics, I believe you have to also have an understanding of the latest standards coming particularly for the automotive, so that this will give you a process of implementation, so that it's not only just automating multiple things, but it is happening in a safe mode. Okay, so I hope I answered your question.
Yes, sir. Thank you so much. So there are many more questions, but I think we're running short of time. And also the panelists are responding in the chat box. Thank you, all of you. So now may I request Mr. Sanjay Muttal to give his remarks and conclude this session.
Madam, with your permission, can I introduce Dr. Sanjay Muttal to the guests out here?
Sure, sir. Sure.
So, gentlemen, let me introduce Dr. Sanjay Muttal to you. So, Dr. Sanjay Muttal happens to be the CEO of Kontempore Solutions. Dr. Muttal comes with more than 3 decades of HR experiences, where he has been at various CXO positions. He's been on the National HRD chapter and still continues to be a very important person on the National HRD chapter. Dr. Muttal is revered and regarded as one of the pillars in the HR industry. And thank you so very much, sir, for making time out, because sir was on another call. Thank you so very much for making your time out, and over to you, sir.
Thank you so much. I was wondering, what is an HR man doing in autonomous vehicle? What am I doing here on this platform this afternoon? But it was such a delight to listen to all the speakers. I mean, for me, automotive or automobile is a very, very dear subject. You know, enjoy driving vehicle, enjoy listening about it. And Tesla is making life come very closer to India now. Hopefully, we are able to see soon some good activity happening in India as well. But I think our experts this afternoon, or this morning, this afternoon rather, demystified a lot of stuff that all of us wanted to understand, whether it was in terms of design, digital, semiconductors, and by autonomous cars themselves. 11 years back, when one heard in 2009 that Google is going to make self-driving car, I thought, I pinched myself and I said, am I reading it right? Am I understanding it right? And then we know for sure now in Phoenix, Greater Phoenix area, Waymo is doing self-driving taxis, and they have commercialized it, I'm told now. So the whole 360 degrees revolution in automotive industry, one has seen in last 10 years, and I think the pace is only hastening up. And therefore, I was extremely happy to be part of this deliberations today. Thank you very much to all the speakers for their time. I always think that while reality of technology is hitting us, a lot of enablers, especially in the Indian context, we still need to put up. Whether it is from the establishment side, with government side, or even from institution like KIT from our side, because only when the enablers are in place, we will see this industry closer home and becoming one of the preferred industry segment for everybody. We have mastered art of technology. We have mastered art of digitization, semiconductors, and so on and so forth. We now need, all the cylinders to fire in terms of the enabling environment, enabling competencies, enabling mindsets, and enabling a student interface. From our side, I think we will be very excited, especially from KIT's side, to partner these organizations, those who are coming here or from where the speakers have come today, because it's been our endeavor to be as close to industry as possible. In fact, we take big pride in KIT University that all our curriculas are structured to need of the industry. And how do we do that? We get industry experts to come and sit with us when we design our curriculum. It's a big effort. Even this year we are doing, revisiting all our curriculums. And we'll be very excited to have some of you also partner our thinking in terms of what the student of today and tomorrow must understand, and especially from the automotive emerging trends and opportunities that you gentlemen are seeing. It will be extremely important for us to stitch some of your thoughts into our own curriculums. So thank you once again for your time this afternoon. We are extremely delighted with your presence. And like many of us on this forum, I was extremely happy demystifying a lot of my thoughts in terms of automotive technologies as we walk ahead into the next decade. Thank you and have a wonderful day.
Thank you.
Thank you so much, sir.
Thank you.
Thank you, sir.
Arindam, now it is over to you.
Yeah, thank you, ma'am. Thank you, everyone, for this live session. A very good afternoon to one and all present here. This is ended a very engaging session. I would sincerely like to thank all the esteemed panelists from different reputed industries for their variable opinion and views on the topic, and also for giving us the precious time. I strongly believe and hope that we can engage with all of you again in near future. With this thing, I also like to thank Dr. Sanjay Muthal and Dr. Kumar Mohanty for their valuable time and their guidance. Our moderator, Professor Suprava Patnaik ma'am, Dean School of Electronics Engineering, for her time and engagement for moderating the session so well. Also, a heartfelt gratitude goes out to the organizing team, Dr. Bhavani Mohanty, Mr. Ashish Gakre, Ms. Charanjit Kaur, Mr. Amit Janamani for helping out through and through. I would like to thank Mr. Debraj Mitra and the whole CR team, Professor Sambhitkar, Professor Israj Ali, Mr. Shomoranjan Mohanty, and the entire faculty and staff members from the School of Electronics Engineering for their valuable support and guidance when I required, and also being an audience. Last but not the least, my lovable students for being a nice and attentive audience and very interactive throughout the session. Thank all of you. Hopefully we shall be meeting you soon, either in person or virtually. Stay safe, take care. Thank you, everyone. Thank you.
Thank you. Thank you so much.
Thank you.
Thank you.
Thank you
very much.
We were almost on time.
Yes, sir.
Yes, yes. Thank you so much, sir.
Thank you, Debraj, and it was nice with everybody. I think we had a good.
Thank you.
Yeah, we should do this again. Thank you.
Definitely, sir.
Sure, sir.
And we'd look forward to have you in the campus again, sir.
Sure, yeah, it'll be my privilege, yeah.
In fact, gentlemen, we would love to have you, talking to students on subjects in detail also. We will have a discussion with Professor Suprava Patnaik, and maybe in the knowledge lecture series that we have in the school on certain topics. I think my colleague, Dr. Arindam Masak and Mr. Debraj Mitra will work it out with the dean, and look forward to seeing you more often. We would love to see you every month also. On things,
Very happy to do things for students.
That's so nice of you. Thank you so very much.
Thank you. Thank you so much.
Sir. Thank you.
Thank you.
Have a nice day. Take care, sir.
Thank you.
Bye.
Thank you, ma'am.
Bye-bye, all of you. Yeah.
Thank
Bye.
you.
Bye.
Thank you.
Thank
Bye.
you, Arindam, sir.
Thank you, sir. Thank you. Thank you,
Thank
ma'am.
you, Suprava, madam. It was very well anchored.
Thank you, sir. It is for the first time.
No, I must say, very well anchored, perfect time management, and wonderful cognitive discussions that we had. I must say, all the participants and students and everybody. So, wonderful job, I think, Debraj and Arindam, in terms of coordinating it. Brilliant. So,
thank you so much, Kumar sir.
Thank you, sir.
Thank you.
Thank you. Good day. Bye.
Bye, sir. Bye. Bye, ma'am.
Bye-bye.
Bye-bye.